Okay, good afternoon, guys. So today we'll see spanning tree protocol. Okay. Before this, how was layer 2 loop formed? How was layer 2 loop is formed? Is created. How was layer 2 loop created? First of all, tell me what is loop? Keep on circling things. Okay. What is layer 2 loop? Any idea?
Loop inside loop.
Huh?
Loop inside loop.
Loop inside loop. No. Okay, what is the protocol data unit of layer 2?
Explain.
Frame. Layer 2 means what? Frame. Frame loop.
Destination not available to continuous loop inside the network.
Yeah, kind of correct. That means, write down one answer. I'll explain you the practical. When multiple frame, when multiple frame, when multiple frame of a single MAC address, when multiple frame of a single MAC address exchange between switches, when multiple frame of a single MAC address exchange between switches due to alternate path, due to alternate path, comma, then loop is created. Then loop is created. I'll tell once again. So when multiple frame of a single MAC address exchange between switches due to alternative path, then loop is created. Okay. That means see. I am having a switch like this. 3 switches. Okay. So there is a broadcast packet came in. Okay. So what this switch will do? He will send it to switch 2 on switch 3. Now this packet has received from switch 1. So they will receive it. Now he got a broadcast packet. So what he will do, he will again broadcast it. He got it from switch 1, so he will not send it back to switch 1, but he'll send it back to switch 2. So what this switch 2 will do? Again send it back to switch 3. So this packet has gone here. Now switch 2 will think, okay, switch 3 has sent me some packet. Now again he will send it to switch 1. Okay, and this packet again switch will send it to here. Likewise, this direction, switch 2 got sent the packet to switch 3. Switch 3. Again he will send it here. He will send it here. So it will keep on sending it like this. And also this. Both the direction. Loop will be created now. Because it is keep on circulating. It doesn't know when to stop only because it will exchange the packet. Again, he will exchange. So when the multiple frame of a single MAC address keep on exchanging between switches due to alternative path is called loop, layer 2 loop. Okay. Now clear what is layer 2 loop? Any doubt on this? No. Write down another question. How STP avoid layer 2 loops? How STP avoid layer 2 loops? Answer. STP avoid loop among switches by STP avoid loop among switches by disabling all alternate path all alternate path towards root switch. All by where you got stuck. Root switch, ROOT, root switch. Written. Okay. Another point, write down. STP avoid layer 2 loops by STP avoid layer 2 loops by blocking a link. Blocking a link. STP avoid layer 2 loop by blocking a link. Okay. And write down STP priority. STP. See, you have a lot of theory part in your STP. Okay. You have to understand and keep everything in mind. That is the only option. Okay. You have to know each and every condition, every values. Then only you will understand how STP actually works. Okay. Just like your subnetting. Very simple thing, but some logics and conditions, if you match that, you'll understand how it works. Okay. So STP priority. STP priority is 32769. In bracket, write it down for VLAN 1. Written. Next one, root bridge election. Least priority. Least priority, and second one is least MAC address. Written. Then you have STP path cost. Ethernet cable, it is 100. Fast Ethernet, 19. Gigabyte Ethernet, it is 4. 10 gig, 2. Written. Now, after that, first point, write down like this point. All non-root bridge switches. All non-root bridge switches will elect root port. All non-root bridge switches will elect root port, ROOT, root port, that is RP. Okay, next point. This port is available only on this port is only available on non-root bridge switches. This port is only available on non-root bridge switches. Written. Next point. Least path cost to the root bridge. least path cost to the root bridge. Always in, next point, always in forwarding state. Written. Okay, next one is designated port. Designated port election. Write down. It can be present on root bridge. It can be present on root bridge as well as non-root bridge. It can be present on root bridge as well as non-root bridge. Okay. Next point, all ports connected directly. All ports connected directly to root port or designated port. All port connected directly towards root port or what port? Designated port. Next point, all ports of a root bridge. All ports of a root bridge or designated port. All ports of a designated, root bridge or designated port. Next point, each link should have a designated port. Each link should have a designated port. Always in forwarding state. Always in forwarding state. Next. Last. Then write down like this. Lowest sender path cost to root bridge. Lowest sender which I written. Then all ports other than root port and designated port are alternative path. That means it is blocked port. Written. Okay. Try to read this for 2 minutes. I'll give you time. Okay. So try to read what on all the conditions I gave, what on all the path cast. Okay. What is a root port? What is a designated port? What is a root bridge? Everything you learn for 2 minutes. I'll give you time. Then I will explain you. Okay. Written. So read. Okay. Okay, take another 2 minutes, learn it properly, especially the root port and designated port points, you learn it. Then only you will understand. Don't understand conditions, you will not. We laughing. Something else is running.
By learning language, like
School. Nostalgic, huh? Nostalgic, huh? Okay. All right. See, first initially I said I'm having 3 switches like this, correct? Okay. They are connected like this. Okay. This is my switch 1, switch 2, and switch 3. Okay. So this is priority 32769. Here also 32769. Here also 32769. That means what? They're all connected on VLAN 1 by default. Okay. See, actually the priority is 32768 plus 1 because of VLAN number. If it's 2, then 770. If it's VLAN 10, 778. Okay, accordingly. But by now, by default, all are in same priority, and this is how my topology is there. Okay. So he is having the MAC address, I will say A. He is having MAC address B, and he is having MAC address C. What is the decimal value of A? 10, B 12, and C is sorry, this is 11, that is 12. C is 12. So which is the least MAC address now? A. What is the condition for the root bridge? Look at your note copy. First is least priority, second one is least MAC address. By default, here priority is same on every switch. Correct? So next condition is what? MAC address. So which is the least MAC address here? A. That is switch 1. So this switch will become root bridge. Okay. This switch will become root bridge now. And these are called non-root bridge. This is also non-root bridge. Okay. After this, you have given 1 point for designated port. Correct? In designated port conditions, I have given every port which are in connected to root bridge are designated port. Can you see that condition? Every port connected to root port or designated port. So which is my root port here? A. So for example, I'm saying this is F0/0. This is F0/1. Okay. This is F0/0 and here F0/0. Likewise, it is the. Okay. So every port is called designated port. So this port, I'll write it down like this. Switch 1, F0/0, F0/1. Switch 2 and switch 3. Okay. Here it is F0/1, F0/1. Okay. So in switch 1, that is my root bridge switch. Every port is a designated port. So this port will become designated port and this port also will become designated. Any doubt on this? No. Very clear. Okay. See, this switch 3 can reach root bridge via 2 ways. Correct? One is via switch 2 and other one is directly connected. So what is the path cost of fast Ethernet? 19, 19, 19. Correct? If he wants to reach this root bridge, switch 3, okay, either he can go by this way or this way. If he goes this directly way, what is the path cost? 19. Other way, 38. So which is the least path cost? 19. So he is obviously going to choose this way. He's going to choose this way. So this port will become root port. This port will become root port. Okay, this is one way. Other way is in your designated port itself, I've given another line. Any port connected to designated port or root port. Sorry, in your root port I've given. Any port directly connected to root port or designated port. So here I have root port. Sorry, in your designated port conditions, I've given this condition. Any port connected directly to root port or designated port. So here I'm having root port. So directly connected is designated port. Correct. So likewise for switch 2, if he has to reach switch A, switch 1, he has this way, another is this way. 2 ways are there. Correct. Again, if he choose this way 19, he choose this way 38. So obviously he's going to choose this way. So this port will become root port. So switch 2, F0/1 will become root port. And here switch 3, F0/1 will become root port. So you can see, you can do it by 2 ways. One is by pathcast. Now you know the root port. Other one is any port connected directly to designated port or root port. For the this root bridge. In your root bridge, any port is connected directly to root port. That port is the opposite port will become root port. Okay. Now I know designated port, root port. Both are in forwarding state. Correct. Now I have to block a link. Then only it will not form the loop, right? So one side if I block, then the loop will not form. So only clockwise will go. So how am I going to do that? See, come here. Here I'm having 2 ports. Correct. So this MAC address is C, that is 12. This is 11. Correct. So the least one, it will take it as designated port. Okay. The opposite side, it will take it as blocked port. Here it will become blocked port. Why? Because priority is same on both the switches. Next, it will go to least MAC. So least MAC address, it will take it as designated port. The other side, it will become blocked. Okay. So here it is designated port. Here it is blocked port. So when a broadcast packet is coming in, okay, it will hit this switch. So he will send it here. Okay. And also here. Now that packet has come here and also here. We'll try to forward it to here, but this port is blocked, so he'll drop it. So this packet, he will again send it here, but in this end, it will block so that the loop will not be formed. We are blocking a port. So this is how a STP will avoid layer 2 loop. Okay. So questions can be asked like any way. It can be a scenario based question. It can be a theoretical question. It can be a conditional question. Okay. Any question can be asked. So simply they might ask you, so they can give you a topology. This is a scenario based question. They can give a topology like this. So which port will be blocked? They will ask you. Which port will be? They'll give MAC address A, B, C. Okay, which port will be blocked? Then A you take it as root bridge, so that will be DP. And according to the path cost, you will calculate everything and then you'll come to know which port is blocked. Okay. Understand little bit? Okay. You want to write down this one in your note copy like this? Yeah. Okay, quickly write down because in future you will forget this. This is just CCNA level topology. Okay. I will today show you CCNP also. So today's class is CCNP switching off STP.
Sir, in this, we have to learn these many rules, right?
Yeah.
Then only we can understand.
Correct. Written? No. Write down, write down. Shall understood? Shall you coming by bike or four-wheeler? Which? Bike. Bike only. Coming from there every day. Written? Okay. Now I'll show you the practicals. Everyone written, right?
Okay. Broadcast to the A itself, then again A will send.
No, it will not send to A because that port only it received, right? If I'm giving you some information, you will pass it to your friends. Same information will you pass it to me? No, right? I'm telling you, uh, you know, oh,
Earlier I was doing because that's what the loop is created because
no. See, a packet has come here. So this packet he will send it to switch 3. So switch A has sent to switch 3 also. So switch 3 is again sending it to switch 2. That packet he is sending to switch A. Not
why
the
is it from switch B.
what?
What the packet is from switch B, you
Uh,
will give it to the switch A.
Switch C. See, switch B is here.
Yeah.
So he will send a packet, he will receive it, and he will send it to switch 3. So likewise, switch 3 has received a packet from switch A, he will send it to switch 2 now. That packet he will again send it to switch A. Like that. Understood? So you will not send the same packet of switch A to A. He is receiving from switch 3. Understood or no? Understood. Now we'll see the small practicals. What I'll do, lay the cursor like this. Here you see VLAN 1, right? VLAN 1. And then you can see the MAC address 00E0. Can you see? Okay. Just write down the MAC address first. Now place the cursor on this router 0001. 0001. Same. But next octet is what? C701. So 0001 C701. Dot C701. Yeah. Now this one C751. Okay. Write down the MAC like this. See, first two octet are same on everything. Correct. What is the third octet? Here it is E. Here it is 0. Here also it is 0. So clearly this is the what? Highest MAC. Correct. Keep this like this separately. Okay. At the bottom. Highest, keep it at the bottom. Now we have to find the lowest one because priorities are same on everything. We are not going to change priority 32769. So next is least MAC. What is the least MAC here? C701 because until 0001.C7 everything is same. Here octet changes the third one, so your 5 is 0, so this will become least. So this will come to top. This you can keep it either way. Like this. Okay. Any doubt on this? Okay. Now I'll connect it. Okay. So least is at the top, other two are the bottom. Keep it like this. After, now here, which is the root bridge? Switch 1, because lowest MAC address. So these two ports will be what port? Designated port. Go to the switch and say show spanning tree. F0/1 is what? Designated port. Correct? And here, this in learning mode. Here, F0/2 is also designated port. Correct? What is the path cost? 1919, because this way he will go. Okay, he is not going to go like this. 1919. Okay. So this timer will come. Priority you can see. Correct. So this root ID is your root bridge. Bridge ID means your own MAC address, everything. So here this is the what? Root bridge. That's why both the MAC address are same. Can you see? But when you come to this switch, so first of all, wait. This is root port, this is root port, correct? Sorry, designated port, designated port. That is fine, right? Okay. Between these two switches, this switch 2 will go this way. Switch 2 will go this way. Path cost 19. Switch 3 also will go this way. Path cost 19. So this port will become root port. This port also root port. That is fine. Here, which is the highest? This one. This is the lowest comparatively. So this port will become designated port, blocked port. That is clear, right? See, F0/1. This one, it is root port. F0/2, designated port. This side. Clear? And here you can see its own MAC address is 0001 C701 C701. Correct? This is the what? Root bridge ID. This one. Bridge ID means its own MAC address. Can you see the difference here? C751. C751. Here C701. That is MAC address of root bridge. So when you say show spanning tree, you will be able to see the root bridge as well as your own bridge ID. Okay? All right. Now come to this switch. Show spanning tree. So F0/1, F0/1, that is what port? Root port, directly connected to DP. This is what? Blocked port. Okay. Now you understood like why this port is blocking. First of all, why we need to block a port and why exactly this port is blocked. Understood? So this is a very basic level diagram or practicals in your CCNA level. Now itself I'll show you CCNP because that makes a lot of sense. Okay. So this is your STP as of CCNA level. There are a few more theoretical part I'll give you. Timer, what are the packets there, laning states and all I'll tell you. After that, we'll see the other practical. Okay. But is it clear for everyone? Any doubt? Offline? Clear, right? 100% they will ask you questions on STP. Be prepared. Okay, write down BPDU. That is Bridge Protocol Data Unit. It is the message that switches use to communicate each other, share the bridge ID. So in your switch 2 and switch 3, you are able to see the MAC address of the root bridge, correct? How you are able to see that? Through this BPDU message. So in this BPDU message, they will share the information of priority, MAC address and all. Through that, they will come to know who is the actual root bridge. Okay, so that is this message. It is a message used to communicate with other switches and share. You can add other switches and share the bridge ID. Written. Next one, you can write it down. STP port states. Disabled, blocked, listening, learning, and forwarding. So disabled means no BPDU, no BPDU message is shared, and no MAC learn. In your blocked, BPDU learning is there. BPDU learn, but no MAC learn. BPDU forward, you can say. No MAC learn. And listening state is also kind of same. That is BPDU forward, but no MAC learn. But in your learning state, BPDU forward, MAC learn is done, but no data forward. In your forwarding state, data forward is also there. Write down these things. Written, guys. So there are 5 states, guys. Okay. First is disabled state. That means STP election, nothing is take place. So that's why you see no BPDU messages transferred, no MAC learn, also no data forward. So there's no data forward on everything. Written. Okay. So disabled state, no BPD is done, no MAC learn, no data forming, simply it's like in your down state. Okay. And then you have blocked state. Here BPD forward will happen. That means he will understand BPDUs, but MAC learn is not there. MAC learn is not there, and also data forwarding is also not there in your blocking port, so that he will not understand who this MAC address is, because MAC he is not learning it. Then comes to your listening state. It is also kind of your blocking state only. Okay, because he is just listening to it. He did not learn it. He's just listening. That means he's trying to learn the MAC address, but not done yet. Where he will learn the MAC address? In your learning state only. Okay. Once it comes to learning state, then BPDU message is forwarded. Your MAC learn is done, but frames are not forwarded. Okay. The PDU of data link layer is frames. That's why it is frames. No data is forwarded. Data means frames. Okay. After learning, then it will come to forwarding state where it will BPDU message will forward, MAC learn will be done, and also data will be forwarded. Okay, here in the topology I've shown, right? FWD was there. That means forwarded state. It is ready to send the frames. Any message comes, it will immediately forward it. That is FWD. Okay, these are the 5 states in your STP. All right. After that, you have STP timers. First is hello timer. By default, it is 2 seconds. That means how frequent BPDU will be sent. Then you have maximum age timer. By default, it is 20 seconds. Information. How long the switch will store information without receiving BPDU? Without receiving BPD. Then you have okay here how much time the switch port will spend in how much time it will spend on listening and learning state. So 3 timers: hello timer, maximum age timer, and forward delay timer. Hello timer, the BPDs will be sent every 2 seconds. Okay. After that, your maximum age timer, that means how long the switch is going to store the bridge ID without receiving the BPDU. That is maximum age timer. Forward delay means you have 2 ports, listening and learning state, how much time they are going to spend there. So 3 states, 3 timers. Write it down. Done. You guys written? Back? Written? All right. What about online guys? Are you guys there?
Yes, sir.
Yes, sir.
Yes. Okay. Offline guys are controlling sleep, I can see. Correct? How many of you feeling sleepy? Be honest. I'll not ask questions. Tell me. Nobody? Good. Okay. Now, So there are multiple STPs. That is, first I'll tell you open standard. That is your STP. Means spanning tree protocol. Okay. And it is using IEEE 802.1d. 02.1d. Okay. And timer is oh, open standard that have STP means spanning tree protocol. Okay. And it is IEEE 802.1d and timer is 50 seconds. How come 50 seconds? Because maximum timer is 20 seconds. Forward delay timer is what? 15 seconds. That means listening 15, learning 15. So 30 plus 20 is 50 seconds. Okay. Here, only one STP. STP for all VLANs. Okay. Second one, you have MSTP. That is multiple spanning tree protocol. Here it is W. Timer is, we say, few seconds. That means 5 to 6 seconds. No, wait. Don't write only one STP. One STP for G or group of VLANs. One S. IEEE 802.1 okay. Then you have RSTP. That is Rapid Spanning Tree Protocol. Okay. So here one W here, 5 seconds, and only one STP for all VLAN. These things you will learn in your CCNP, other STPs, MSTP, RSTP, and all. Written, guys? This is open standard. Now I'll show you Cisco proprietary. Cisco proprietary, first one we have PVST plus per VLAN spanning tree. Okay, that means one STP for each VLAN. Two is RPVST plus. That means rapid. Your timer is 50 seconds here. Here, one STP for each VLAN, but timer is few seconds. Written. So these are the different STPs we have. Open standard, we have STP, MSTP, RSTP. In Cisco, you have PVST plus and RPVST plus. That means if you have multiple VLANs, how it is going to behave. Your STP doesn't involve multiple VLANs. Okay. So if you want multiple VLANs, then you should go with MSTP. So multiple spanning tree protocol. So for a group of VLAN, you can create a different STPs. Okay. All right. Now, one more thing. Write down, that is port fast. So if port fast is enabled, write down on a interface, then the interface will instantly move to forwarding state. Then you have BPDU. If BPDU got is enabled on an interface, it will wait for BPDUs and if any BPDUs and if any BPDU is received then BPDU guard will block the port. Write down these two things, I'll explain you. Written. So what is this port fast? If I'm going to enable the port fast in the switch, then the switch will not spend time in listening state, learning state, blocking state, nothing. Directly it will go to forwarding state. For that purpose, we are using this port fast. Immediately it will go to forwarding state. What is this BPU guard means? See, if I'm having 1, 2, 3 switch, which is the least MAC, this one. Okay. Now if I connect another switch here, then what will happen? Again, he will send BPDUs and he will become the root bridge. Correct? But I don't want this switch to be a root switch. In that case, what I'll do? I'll enable my BPDU guard here. BPDU guard. So if a BPDU comes here, you will just block it. So that he can't become root bridge. He'll become non-root bridge only. For that purpose, we are using this BPDU guard. I'll show you this all practicals in your NP. Okay. So here, this is as of your CCNA level. Okay. So what you have seen? How layer 2 loop is formed. First, what is loop? Okay. What is layer 2 PDU? How it is forming? Okay. How STP is going to avoid? There are multiple conditions. So it is electing root port, designated port, root bridge, non-root bridge. Then it is blocking the port which is in the highest MAC address. So this is how STP works. Okay. All right. Now we'll see another practicals. Okay. Now we'll write down the VLANs. MAC address 0001, 0005, 0000A, 0030. This is 0001. This is 0005 here, 0A, and then 0030. Correct. Which is the least? 0001. Correct. So this will go to top. Okay. Then I have least that I'm keeping here. The highest will be at the bottom. Then now I'll connect it. I'll say 8 connect to 9, and then this side of 8 connect to 9. Okay. Here I'm connecting with 10 to 11. Again, this side of 10 to side of 11. Okay. 8, 9, 10, 11. So here I'll connect it with 12, 13, 12, 13. Done. So this side 8, 9 is over. So 10 connect to 11 and 10 connect to 11. Okay. So I have 10, 11 connected here. So here I'll connect it with 8 to 9. Again 8 to 9. Done. So after that here 8, 9, 10, 11, 12, 13. So 8, 9, 10, 11, 12, 13. 12 to 13. 12 to 13. Okay. Looks fancy, no? So this topology, if you understand, then you don't have to worry about STP at all. STP will become very easy for you. Okay. So here clearly, which is the root port? 0001. So every port on that port will be a designated port. No doubt at all. Designated port, correct? Okay. Let's go and check. Every port is a designated port and all are in forwarding state. Okay. This is fine. So here you can see root ID 0001. Bridge ID is also 201. That means this itself is the root bridge. Okay. Now come to this switch. Which one? Or I'll take no, I'll come to the switch 3. Okay. In switch 3, so we are having first, we'll come to these two ports. Okay. So which is the least mark between these two? This one. Correct. So he will become, these two will become designated port, correct? That means F0/8, 0/8, 0/9, both will become designated port. Between these two, that is this switch 2 and switch 3, which is the least? Switch 2 is the least. Correct. This is the highest. So this side will become designated port. Here it will become blocked port. Okay. This side it will become block port. That means 11 and 10. No, sorry. 10, 11, 12, 13. 12 and 13. 12 is blocked and 13 is also blocked. Okay. Is it clear? These two ports, why this is DP, why this is blocked? Here it is highest, so it has become blocked. Here it is lowest between these two, so it has become designated port. That is clear. Now come to these two ports. See, I am having a switch, two switches like this, connected like this, correct? This is switch 1, switch 3. How they are connected? 10 is connected to, see, initially if it's like this, okay. If it's 10 is connected to 10 and 11 is connected to 11. Okay. So this is a designated port. This is also a designated port. Correct. So only one port can be active at a time. Correct. So which is the least one? 10. So 10 will become root port. 11 will become blocked port. Because only one link can be active at a time. So that is the reason this will become blocked port. So if this switch has to send any message to this switch, how you will send? Via that 10 link, you will go to root bridge and root bridge will send it to this switch. Okay, because podcast is 19. Here also 19. Here also 19. Here also 19. Here also 19. So for this switch to reach root bridge, he will obviously use this way. Least path cost. He is not going to use this way because 19 plus 19 will become 38. If he's going to use this, 19 plus 19, 38. This is 19. So directly we'll use this. Correct. And they are connected with 10 and 10, 11 and 11. Just imagine. In that scenario, 10 will become root port, 11 will become blocked. But interviewer will twist the question. He will say 10 is connected with 11. And this side of 10 is connected with this side of 11. This is 11. 10, 11, 10, 11. So now which port will be blocked? This is the question. No block port. Without blocking port, how the loop will be avoided? You have to block a port. See, here one point I've given. Lowest port sender post ID. Port ID. Check your notes. Lowest sender port ID. Correct? Correct. There, here always look for the root bridge. Switch 1 is the root bridge. What is the lowest? 10 is the lowest. So 10 is connected to which one? 11. So this will become root port. This will become blocked port. The lowest of sender UC. That means root bridge. Root bridge, say lowest is what? 10 only. 10 is connected to 11. So this side of 11 will become root port and 10 will become block port. See here. First come to these two, 8 and 9. 8 and 9, this is the lowest. So 8 is what? Designated port. 9 is also designated port. That is fine. Correct? This side. Here it is blocked. Which one? 12, 13 is blocked because 2 is the least. So you can see 12 is blocked BLK and 13 is also blocked. This is fine for you. Where you get confused between these two, root port which I should connect, which I should select. In that scenario, lowest root bridge. Okay, 10, 11 are connected, 11 and 10 are connected. So least of your root bridge is what? 10. That 10 is connected to 11. So 11 will become root port and 10 will become block port. Okay. Usually people make common mistakes. 99% they are making mistakes. So they will say least. So they will say 11 as blocked port. 10 they will choose as root port. But that is wrong.
Both of same.
Both are same. 10 will become least root port and 11 will become block port. 10, 10.
Then same.
Then same. See, same is easy because you have 10, 10, 11, 11. Least one is 10, you choose it as root port and 11 you will say designated port. But 10, 11, 10, 11. There only problem comes. So this is the very important thing you have to understand. Always look for the root bridge least. 10, so 11 will become. Understood? Online guys, any doubt on this? Say, look at the difference between CCNP topology and CCNA topology. Correct? In CCNA topology, what we are doing? Only 3 switch, 1 link, 3 link. Here, how many links we have taken? 2, 4, 6, 8, 10, 12 links. Correct? So if you understand this, then it makes sense. Okay? All right. Now we'll go to switch 2. Switch 1 is over. Switch 3 is over. Now go to switch 2. First connect with these, check with these two. This will become designated port obviously because this is 003, here 0005. Here again, this is 000A, here it is 5. So this is again designated port. But problem is, confusion happens here only. Connected like this, 8 to 9, 9 to 8. Correct? This is my switch 1, this is my switch 2. Correct? So lowest path cost. What is the lowest here? 8. 8 is connected to which one? So 9 will become root port and 8 will become block port. Okay. So 9 is root port, 8 is block port. Let's check. So 9 is root port, forwarding state, but 8 is blocked port. Other than that, everything is designated port, because this is the least, second least. Okay. Understood this switch? Any doubt? No. Now we have this. This one is very easy because everything you're going to block here. This is the least here. DP. So opposite side it will be blocked. Here again DP. So again it will be blocked. Correct? Now we have this two. So 12, 13, 13, 12. So 13 will become root port. 12 will become blocked port. So except 13, everything is blocked. Simple. So here I have 13. That is root port blocked, forwarded. Other than that, everything is block, 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 block. Okay. So that when they are going to send the frames, they will just block it. It will not be looped. Only one direction, that is through via root bridge, you will be sending the packets. So, sorry, frames. Okay. Any doubt on this? Okay. Just quickly write down, like draw this topology in your note copy. What I will do. First write down for switch 1. So F0/8, F0/9. F0/8 is what? Where is 8? 8 and 9. So everything is DP here, correct? Write down designated port, designated port. Write down. Draw this topology first. Okay. Write down, this is 8, 9. Here it is. Let me drag it. I'll write it also for your understanding purpose. Don't get confused. So here 8, 9. 8, 9 on this side, 10 and 11 on this side, 12, 13. Likewise here, 8 and 9 here, 10, 11. Here it is 12, 13. Here 10, 11. Here 8, 9, 12, 13. Draw this diagram first. Switch to F0/8. So 9 is connected to 8. So 9 will become root port. 8 will become blocked. Block. Other than that, everything is designated port. Designated port, designated port, and designated. For switch 2. Switch 3. 8, 9 is designated port. Designated port. 12, 13 is blocked. BLK. 13 is also BLK. So 10, 10 and 11. So 10 is connected to 11. So 11 will become root port and 10 will become block port. Then you have switch 4. So everything is blocked except, so we have 12 and 13. So this 12 is connected to 13. So 13 will become root port B L T blocked. Write down this one. And to check the thing, what is the command? Show spanning tree.
So the same it is highest, so having your number will be a block.
Correct. Written. Some people are writing. Write down, write down. See, every port, how many ports are there? 6, 12, 18, 24 ports are there. You should clearly understand all the 24 ports. If you don't understand one port, that means I got 23 right, but only one is wrong. Then also, you did not understand completely, meaning. So all 24 should be right. I'll give you some task for tomorrow. And Dinesh, please don't send me message.
Okay.
He was so angry at me. Dinesh, you keep on asking me, did you do practical? Did you do practical? Wait, I will send you all practicals from proxy RP you're sending. No?
Yes, sir.
You finished all the practicals. Wait. What was Sandeep doing practicals or not?
Yes.
Wait. What was the last practical unit? Huh? What? What was the last practical you did? You don't remember? What was the last topic that we discussed?
Which?
Switch? What VLAN? No, not VLAN. What was the last exact topic we discussed? Not for you, I'm asking Sandeep. What was the last topic that we discussed? You? Seeing there. What was the last topic that we discussed? VTP. Before that,
ATP.
question is for individual. Okay. Go through it because in a week, CCNA is over. By next week, by now, CCNA is done. It's been almost a month. We'll stretch it to next week, 2 days also. Okay. If everybody are okay for Saturday's class, then we'll see accordingly. Okay. Let's not rush. So return this spanning tree. So for tomorrow's task, I'll give you. Now you understood clearly, no doubt. But within a week, you will forget. So that is the problem with spanning tree. a regular practice, regular understanding of the conditions, you should be keep remembering it. Then only you'll be able to solve. Okay. So I'll give you a couple of tasks. So first task is you're taking this 3 switch. Just always go with 3 switch. So you're taking 1, 2, 3 switch. Okay. Switch 1, switch 2, switch 3. Here keep the least one. Connect it like this. Understood? And here the second highest, and here keep the second highest, and here keep the third highest. Okay. And take your note copy. Okay. Write down like what I did. Switch 1, 0/1, 0/2. Likewise, switch 2. Okay. Likewise, switch 3. And go to, once you arrange the topology, go to that particular switch and say show spanning tree and verify it and do your self correction. This is one topology. So you're going to do 4 topologies. This is one. Next one is what? Same 3 switch. Connect it like this. Okay. Keep the switch 1 here, switch 2 here, and switch 3 here. That means least MAC is here. Least MAC. Here keep the highest MAC. Highest MAC. Okay. Or you can keep here also, it doesn't matter. But least MAC should come down. Okay. And again write down like switch 1, switch 2, F0/1, 2, 3 and do the self verification. Here you're not giving any command. Simply arranging the topology and you're saying just show spanning tree. Okay. Your understanding thing you will know in your notes. Okay. All right. This is 2 topology. Next topology is four switch. 1, 2, 3, 4. So least is here, highest is here. Okay. Connect it this way. Say here say 11, 12. So this side 12, this side 11. Use the crossover cable. Okay. So here. Okay. So here take 13, 14, 13, 14. Take this like this. 15, 16, 16, 15. Okay. Okay. Now here 13, 14 is done. Here take 15, 16. No, sorry. 13, 14, wait, 11, 12. 11, 12. Here 11, here 12. Here what will it become? 15, 16. 15, 16. Now only one thing is remaining. What is that? 10, 11. So 13 to 14. Here side, this side 13 to this side 14. Like this, you're going to arrange. Same way. 10, 11, 13, 14, 15, 16. Okay. Here, keep the least one. And check, like, write down all the interfaces. 24 interfaces. First write it down. Switch 1, F0/ what? 11 to 16. Likewise, switch 2, switch 3, and switch 4. Keep the least MAC top, highest MAC down. And check. All 24 ports should be correct. All 24 ports should be correct. Then only you understood. If not, do it again. This is one topology. Other topology, ulta. Keep the least here. Least come down. Highest here. Okay. Second highest here. Okay. And then the other switch here. Just keep change the switch. Concept is same. If you understand the concept, you will be able to do it. This is one topology. So 4 topology you're going to do. Okay. Any doubt on this? Okay. You want to write down this? No. Recording is there. You will see it. Okay. Bye. Use this cable. You see copper crossover, control and click this. Then it will work. All right. So what's the time? 3:35. Should we go for another topic or we'll see tomorrow? Today's STP is over. Up to you guys. Decide. Tomorrow. Because STP is little too much. I know the conditions. Okay. We'll see the topic tomorrow, but nobody is leaving. Sit and do it now only. Learn all the conditions now. I'll ask questions. I'll end the meeting. Okay, I'll stop the recording, but I'll ask questions on the conditions now. Immediate interview. Online guys, any doubt? Please respond. Who's Arila Manoj? Oh, man. Who's this guy? Oh, Suday, right? No, sir. No. Okay. No. All right. Good. Okay, guys. Then I'll see you guys tomorrow online, guys. You can leave the meeting. See you tomorrow.